Hello, everyone, and welcome to episode 8 of Clay Loves Logic, where on this channel I solve logic-based Sudoku puzzles and any sort of puzzle like that I find interesting. Today we're going to be solving the puzzle Corners of Luck by Fractal Minding. As always, I'll put the link to this puzzle in the description so you can try it out if you'd like. Now, with that, let's get into the rules. And there's not many today. Normal 6, well, it doesn't say it, but normal 6x6 Sudoku rules apply, just as normal Sudoku rules apply. What that means is you have to have the digits 1 to 6 in every box, in every row, and indeed in every column. And then we get the rule that each orthogonally adjacent digits are non-consecutive. What that means is this could never be a 3, neither could this. This could never be a 2. And that is all the rules we get, and apparently we can solve the puzzle with that information. So let's give it a try. I'm just going to start pencil marking a couple things. 2 seen here and here. So there's a 2 here. Same trick works for this. One of these is a 2. For this, doesn't. Any of these can be a 2. And for this, just one of those. This can't be a 2 because of there's the fact that there's a 1 here. So what about 4s? 4s will only be interesting quickly because none of these digits, orthogonally, sorry, just those. Okay, that's less interesting. There's loads of places a 4 can be. So 3s have to be from here. 3s have to be from here. Lots of places a 3 can be in these boxes. But I suppose, yeah, no, there's lots of places. There's lots. Okay. Well, what about the fact that we know one of these is a 3? What does that tell us? Well, that tells us that neither of these could be a 4, right? Because one will always be a 3. So the other one couldn't be 4. It just couldn't be. So one of these is a 4. And it's only a 4 if one of these is a 3. If this one's a 3, this one could be a 4. And that's going to be interesting too, because so where's 5 now? If one of these is a 4, well, either could still be 5. Either could still be 5. But then if either of these is 5, this is 6, and that works. What if it's 5? And if there's a 5 here, this is a 3-5 pair. Oh, and that's going to break it, actually. Oh, that's cool. That is cool. That is very cool. I'm going to slow this down. So what I was saying is, what if this was a 4-5 initially? And then I thought this is a 3-6. Yeah, that's okay if it's 3 and 5 and 4 and 6. And in fact, that is what it is. But let me back it up, because the way I proved it in my head was just thinking, okay, well, that's valid. So but what if this was a 5 and then this was a 6? Maybe is that what we just did? That is what we just did. What if this was a 5 and then what if the 6 was over here? 3, 6. Yeah, that's fine too. Well, what did I see? If this is a 6, this is a 5. You're always going to have, well, this could never be a 5 if this is 4, 6. This would have to be 3, 6, 5, 4. And that's valid. Let's just, oops, lost a couple. So because this is a 3, there's always a 4 here. There's always a 4 here. Where do we put 5? If we put 5 here, we put 6 here. This digit could be 3, 5, 6, 4. That's valid. Okay. Unsure, actually. I thought I figured it out. I thought I had an aha moment, but I just didn't. But we know that there's a 4 over here. And I don't know if that's helpful yet. And then we get, 5 and 6 in some configuration. But I'm gonna try to make a couple claims here. Is there ever a world where this is a 5? Knowing that this is either 4, 5, or 6, those are the only three options. How could this ever be a 5? What could it pair with? Well, it couldn't pair with 5, obviously. But it couldn't pair with a 4 or a 6. That can't be a 5. That's actually okay. So there's a useful deduction. Can we take that a step further? Anywhere else? What about this? If this is a 5, this could be 3. This is a 6, this could be 3. If this is 4, this could be 6. All of that's fine. And then what about this? If this is a 3, this is 6. If this is 3, this is 6. This is 4, this is 5. That's valid. Okay. Let's move on. And we can actually do something that is interesting and probably where I should have started the puzzle, which is simply we have to put a 2 in one of these 3 spots. So can we put a 1 here ever? I guess if it's there, yeah. That would be the only thing. It would have to be 1, 2, 2. But I'm going to pencil mark other places that could be 1s. Again, I thought I had something better than I do. The break-in on this puzzle's tricking me. Maybe we have to use this 5 in combination, right? To say that somewhere down here, there's a 5, and does that help us? Well, it does help us because we have the same thing that happened here, right? Where if this is 4, 5, and 6, how could this ever be 5? What could this go to? Nothing. So 5 is in one of 2 places. And is that interesting? Could it be here? 5, 3, 6, 4. 5, 3, 6, 4, 5. Yeah, it could. Could it be here? Probably. Yeah, I can't see any reason why I couldn't yet. But now we know that we always knew that the 3 was there. Actually, that's silly. Boy, this puzzle is just tough one to crack. Well, we know that there's a 4 somewhere in this row now. And that's useful only because it's not there. And could the 4 ever be here? And I'm going to claim it could. Damn, it really could, couldn't it? 4, 5, 3, 6. Oh, no. 4, 6, 3, 5, 4. All that's fine. So there could just barely be a 4. If this is a 4, okay. So now what about 5s over here? Maybe we can do some work over here. Where are we going to put a 1? Somewhere there. We have a 2. We're going to put a 3 somewhere here. We're going to put a 4 somewhere there. And we're going to put a 6 somewhere there. So this has to be either 4, 5, or 6. And again, that lets us take out this ability to be a 5. Because if this is 4, couldn't be a 5. If this is 5, couldn't be a 5. If this is 6, couldn't be a 5. So we've actually narrowed 5 down to 2 spaces. Which seems like, I'll take any sort of help I can get at the start of this puzzle. This is surprisingly difficult. Okay, so now we know that these 2 are both digits 4, 5, and 6. So is there a world where this is a 6? And I'm going to say that it can't be. Because if this is a 6, then these are 4 and 5. And there's always going to be a 5 touching the 6. And then I think we can do the same thing with 4, right? Because if this is a 4, this is always 5 and 6. And no matter what, there's a 5 touching it. So actually, we can take 1, 3, so we can take 4 out of here. And we have a proper 1, 2 pair finally. And I feel like that's a real break-in because a 1, 3 is going to let us take 1s out of here. And now 1 is up here for sure. And now we know that this is from 2, 4, 5, and 6. I'm not going to pencil mark that in just yet. But if this is a 3, we'd have to have 5, 6, 4, 1. That's all fine. So what if this is oh, that does it. That gives us our first digit. Wow, what an earned digit. Look at this. If this is a 1 or a 3, is this a true pencil mark that this is only a 2 and a 4? I don't think it is. Shit. I don't think it is. 1, 2, 4. I don't think that's a true pencil mark. What's stopping this from being a 5? And I want to say nothing. Wow. Wow. We have 3. Yeah. Here I thought we had a sure thing. I thought that was, but this could be a 5. This could be a 6. This could be anything. Why did I have a true pencil? Why? Damn it. Yeah. Because we know, well, yeah. Wow. This puzzle is relentless. Can we do anything with this 3, 5, 6 using some of the tricks we've learned up here? If this is a 3, 5, 6, this is a 6, 3, 4. No, we just can't yet. So what do we do if this is, because I guess this could probably just be about anything other than 1, 3. Well, and actually, better to start with, if this is a 1 or a 3, there's no world where this is a 2. It could just never be a 2. That's in the middle of both of those digits. 1, 3 is true. That's the only true. Oh, that gives us a digit. Wow. Because we know that 1, 3 is true, which means these digits have to be 2, 4, 5, 6. How could this ever be a 2? There's 1 or a 3. Both of those are adjacent. We get a 2. This is no longer a 2. And we know there's a 3 up here, and it's not here. So there's a 3 either here or here. And that's starting to be relevant. This is now a 4, 5, or 6. And now, knowing that these are both 4, 5, and 6, we can't do any tricks with that yet, but we know that this could be, well, what could this be? This can't be 1 or 3. So this is, oh, this is 4, 5, 6. And this is not 4. This is 1 or 3. And there's definitely a 5 up here in the 2 spaces. There's a 5 down here. This could be, okay. Well, actually, you know what? Now we're starting to move through this puzzle a little bit. I feel like we're almost making progress. One of these is a 2 for sure. Has to be. Unequivocally, one of these is a 2. And I'm going to put a proper corner mark to let me know. I don't want to mess that up. These pencil marks are a bit disastrous, I want to say. Oh, and actually, that gives us another. This has to be 1 or 3. This can't be 2. 2's down here. This is not 2. This is 2. This removes 2 and 1. Neither of those could be. In what world could they be? They couldn't. So this is going to be some sort of 2 like that. But moving on, this is now only 4 or 5. So this could never be 5, right? Because if this is 4, this could never be 5, and they can't be double 5. So this is a 3, 6 pair. This is a 3, 6 pair. Hell yeah. Okay, how do we? Okay, so we gotta get this thing for sure. We have a 3, 6 pair. We have a 3, 6 pair. We have a 3, 6 pair. This is a 1. Yes. This is not 6. That's a 4, 5 pair. 4, 5 pair. Great. Awesome. Okay, great. This is great. What's next? We need 3, 4, 5, 6 in these digits. This can't be a 3 because the 3, 6 pair is here. Oh, this is a 3. So, oops, 3, which means we have a 3 in the middle. It's not there. That's a 3. Has to be. Can't be here. Can't be beside a 2. So what else do we need? We need a 1 somewhere over here. And we need a 4, 5, 6. Well, buddy, none of these are 4. They're all next to a 3. That's 4. And if I could pencil mark right once in my life. This is 5. So what do we need? This is a 1. This is a 6. What an awesome start to this puzzle. This can't be 6 anymore. What do you mean? It can't be 6. It's sequential. That's a 6. This now has to be a 4. This is a 5. This is a 6. This is a 4. And then this can't be a 4 or a 6. This is only a 5. That's going to give us 4, 6 pair, a 1, 3. That's going to give us a 5. Keep typing in the digits wrong. This resolves because it can't be a 3. That's a 1. That can't be a 6. That's a 4. Can't be a 4. That's a 6. What do we need here? We need 1 and 3. So that's a 3. That's a 1. What do we need here? We need 2, 4, 6. This can't be 2 or 4. This is 6. This can't be 2 anymore. This is 2. So this is 2. So this is 4. So this is, what do we need? We need a 4 and a 6. So this is a 6. This is 4. Down here, we're going to need a 1. We're going to need a 3. We're going to need a 5. What a fun puzzle. Wow. 78 people solved this in 4.5 hours, 15 minutes to solve. That was a fun puzzle. I thought I was going to have to color that. That was a tricky break-in, but I feel like I'm just not very good at those consecutive puzzles. Orthogonally adjacent digits being non-consecutive. I'm trying to get better at them. So this was a fun practice, but I just noticed something interesting I wanted to point out. Look at this. Puzzle ropes. I could have picked up on that earlier. You only ever have odd digits next to each other. And I guess, wow, you know what? Maybe that's the way to start the puzzle. Because when you think about it, in a 6x6, you have 3 even digits and 3 odd digits. And if they're ever beside each other in a row, or if they're ever not exclusively beside each other in a, a section like this, how do they not touch? 1, 2, 5, 2, 3, 6. Maybe that was the way to start. Something about that, in thinking that, if you have a 2 here, you have to have your even digits, and you have to have your odd digit, or sorry, you have to have your even digits here, you have to have your odd digits there. Maybe that was the way to do it. Or is that true? I don't even know. I don't know. Fun puzzle. Very fun puzzle. Quick solve. Good one. I hope you enjoyed it as much as I did. Catch you next time.